Welcome to ProfRomi series, Making the Point, Unlocking Madness Behind Methods. I'm ProfRomi, and here to explain to you why ecologists do things a certain way and then help you learn these skills. Episode 3, How Degrees of Freedom Remind Me of Minions, How to Put Them to Work for You. One of the challenges in teaching about methods comes from connecting students to the intangibles. The field of statistics, in many cases, seems abstract and not real. In this episode of Unlocking the Madness Behind Methods, I want to change that by first talking about minions. Yes, you heard right, minions. This is a minion. Note that the minion is dressed in work clothes. Did you know that the term minion comes from the 16th century French, and in some cases confers affection? Although minions follow a leader, and sometimes an evil one, and might appear simple, a lot of complexity and power exists behind a group of minions. Power exists in numbers. Minions work hard and help others. They have helped Universal Studios all the way to the bank. By the end of this video, students will be able to 1. Visualize statistics in action. 2. Find the critical value for any given statistical test. 3. Compare that critical value to a calculated and address a hypothesis. And understand the relationships between replication, degrees of freedom, calculated and critical statistics, and p-values. The most important thing to know about statistics involves understanding what it means to reject or fail to reject a null hypothesis and how that depends on degrees of freedom. As part of the nature of science, researchers never accept the result, but instead reject possibilities and come up with alternative ideas. Degrees of freedom help confer power to statistics that help detect a statistically significant difference. When I think about unlocking the madness behind degrees of freedom, I think about the mutated mad minions like purple. Now, these minions worked for evil, but they originally came from the good minions. Think of degrees of freedom as an army of these crazy minions running around knocking down critical values for the purposes of good and not evil. Reducing the critical values makes it easier for the calculated statistic to exceed the critical, which is the hallmark of statistical significance. To make sense of the role of the minions, remember I think of them as degrees of freedom, take notes that confidence in a percentage is 1 minus the p-value. The p-value is the probability that the result is not due to chance. Significance means that the calculated test statistic is greater than the critical one. Critical statistics depend on degrees of freedom and a priori alpha level, and degrees of freedom is the number of replicates minus 1. Critical values represent another abstract idea associated with statistics. Computer programs such as Excel and SPSS have critical values embedded into them, and they automatically come up with a specific p-value based on the significance level and the degrees of freedom. However, before the computer age, one looked up the critical values in a text of tables. Yes, an actual book. Look at this example of a table of critical t-test values. This table works for this test. There are other tables for different statistics. Remember, you need the right critical value to compare against the calculated value from different equations. Notice a couple of patterns. Number 1, significant levels can vary. We use the column for significance levels of 5%, or alternatively a 95% confidence standard. This is normal practice. Number 2, notice that critical values get much larger as you go horizontally across the table. It takes a much higher calculated value to achieve 99.99% confidence. Number 3, you will notice that critical statistics decline as degrees of freedom increase. Increasing degrees of freedom makes it easier for the calculated statistic to exceed the critical. Let's make this a little more real. Let's say that you have 2 groups of 10 bunches of bananas. You want to find out which bunch holds more bananas on average. Your null hypothesis states that no difference exists between the number of bananas per bunch. You call on your minions to help you answer the question. Did you know minions love bananas? How many minions are in your statistical army? This is how you calculate it. For each group of bananas, degrees of freedom is n minus 1. So degrees of freedom in this case is 10 minus 1, therefore 9. But you have two groups, so 2 times 9 is 18. You have 18 degrees of freedom. For 95% confidence, a 5% opportunity for chance, with 18 degrees of freedom, use the table to find the critical t statistic. Hit pause, rewind, and then return to this point when you have it. You should have determined critical test statistic equals 2.101. Great, now what? What do you do with a critical value? Well, you compare it against a calculated one. In the case of two groups, you can calculate a t with the following formula where x represents the averages of the two groups, s squared refers to the standard deviation, and n equals the number of bunches of bananas. Now, pretend that your minions can rapidly crank through some math and come up with a t-value of 2.18. What's next? You then compare that 2.18 against the critical for the determined degrees of freedom and confidence level. So calculated 2.18 is greater than critical of 2.101. What do you decide? You decide to reject the null hypothesis that bunches have equal numbers of bananas. A significant difference exists between them at a p-value of less than 0.05. Keep in mind you will often not get as precise a p-value from a book as you will get from a computer. Now, let's change up the parameters. Hit pause and think about it after you hear these two statements. Imagine that you had two less minions in your group, but the same calculated t. Does your critical value change? Does your conclusion change? What if your calculated t came out as 2.09 instead of 2.18? Welcome back. I hope you've thought about these things. For question 1, your critical value does change from 2.101 to 2.145. However, your decision to reject the null hypothesis remains the same because 2.18 is still bigger than 2.145. For question 2, your calculated value no longer exceeds the critical with either 14 or 18 minions. Calculated 2.09 is less than the critical of 2.101 or 2.145. Now, ask yourself, how many more minions would you need to find a significant difference? Answer, you would need 20 minions to help you drive down the critical value. Now to connect the dots. Imagining your army of crazed minions batting down the critical values left and right. They work to make the result significant. That explains the madness behind the method. To test your understanding of the concepts presented in this video, hit pause when the next slide appears and take a minute to complete the following graphs. The values increase from bottom to top and from left to right. Hit play when you're ready to review the answers. If you captured the ideas present in this video, then you would have drawn a positive relationship between replication and degrees of freedom. Each replicate gives you one more minion. If you understand the role of degrees of freedom, then you would have drawn a line with a negative slope. With lots of minions, critical statistics remain small. The remaining two lines also have negative slopes, as high critical statistics result in a low likelihood of rejecting the null hypothesis. Alternatively, a high calculated statistic shows an inverse relationship with a p-value. Low p-values mean that a large calculated value greatly exceeds the critical. Congratulations! You now have a much better understanding of degrees of freedom. This brings us to the close of the ProfRomi episode, Making the Point, Unlocking Madness Behind Methods. There's no expectation of homework for this episode, but expect to see these concepts reappear on your final exam. I hope now that you see that replication has a point because it builds up degrees of freedom, and everyone needs an army of minions to help them get through life's challenges.